Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math basic course. And as always, it is an honor and a privilege to be serving you here today, as it is every day, here in my virtual classroom. Stepping aside as we go into the Big Ideas Math Integrated Math 3 textbook on sections 1.1 and 1.2 quiz review. I only have 8 questions of these in the problem set. They all have to do with density. Population density from section 1.1, volume density, or just basic general density from section 1.2. And they all coincide together. We'll see what kinds of questions they ask. Like I said, 8 problems, but they have some parts A and B, it looks like, at the end. Hopefully it'll be a quick one. Jump down to the description section down below if you want to find a problem set, specific time in the timestamp section for the problem set, and also download the PDF of this single page entity as well. Grab a calculator. Seems like we're using them a lot. Away we go. We start with section 1.1 material. Number 1, the state of Wyoming has a population of about 564,000 people. The population density of the state is about, I can't read, 2.16 people per square kilometer. Find the width of Wyoming. So they're looking at Wyoming as basically a rectangular thing right here, and its length is given. So if area is length times width, right, we have 579 kilometers times width. So I'll just say square kilometers for that. Let's make sure our density is it is square kilometers, which is good. We always have to check on those things as well. So there's our thing in terms of, there's an area in terms of width, right? We don't know what the width is yet. That's something we're going to solve. Now the density is 2.16 people per square kilometer. And then we have population of 564,000 people. So population equals 564,000 people. Okay, so our formula to find the density of something, which we have, density is going to be population over area. So we have a density of 2.16 people per square mile equals, here's our population, 564,000 people divided by this number of square miles, 579 W. This is our goal, basically our way of trying to solve for W. Now, it takes 2 steps from here algebraically to solve. I don't even need to keep 579 and W together. They're multiplied together in the denominator, but I have to get W up in this numerator. So multiply both sides by W here, and I can divide both sides by 2.16 here. That's going to get me to where I need to go. 2.16 will now multiply by 579, and W will be by itself. So W equals 564,000 divided by whatever 579 times 2.16 is. That'll be the width of Wyoming, or the height, like whatever you want to call it, the other dimension. So width, again, 564,000 over this 579 times 2.16. And I'm actually putting this in parentheses to emphasize if you use this in one step in the calculator, you got to use parentheses around that thing. Otherwise, you might have an order of operations hiccup there. So I'm going to go and do 564,000 divided by, in parentheses here, 579 times 2.16. Or you can do that part first and then divide it and whatever, but this should work out. I don't know, did they say to the nearest something? Let's see. Find the width of Wyoming. We can say to the nearest kilometer. So this will be around 451. 451 kilometers for that of Wyoming. Nicely done. I guess it could have been done a little bit faster, but I love some explanations as we're still moseying through the actual sections, right? We're still kind of learning as we go. And that's number 1. Number 2. If only every problem will be that duration. We'll see. A circular region, not Wyoming, with a 3-mile radius has a population density of about 6,195 people per square mile. Find the number of people who live in the region. So they're showing miles and miles, right? So we have the area of our region as pi times 3 squared. It's a circular region. So 9 pi square miles. There's our area. We are trying to find the population. That's unknown. We have our density, 6,195. So we're not solving density. We're using density to solve and find some other things. This is people. Okay, let's use that. Density equals population. That's our unknown over area. So I'm going to multiply both sides by 9 pi. That'll get me this one, 6195 times 9 pi. And yeah, I'm going to multiply the pi portion as well. There's going to be rounding to be had, and we'll round to the nearest person, right? We won't use decimals of people. So 6195 times 9 pi. Assuming I didn't mess anything up there, we got 175,159.49. 1.84. Just got to round down there, so I'm going to say 175,159 people. 175,159 people. Peoplation, folks. That's what we're getting on that one. Okay, let's move to numbers 3 and 4, where we describe how the change affects the surface area of the right cylinder or the right cone. And I think we're still in that nature where we do have to do the calculation in the division. I'll say the answer out loud if I know it, but I think we're supposed to actually compute them. So multiplying all the linear dimensions by 1/3, making everything 3 times smaller, we're talking about surface area, not volume. So everything, the answer is going to be 1/9. The surface area of the smaller one will be 1/9 it, because you square the 1/3. But we don't know that yet, right? So let's go ahead and talk about surface area of a cylinder. You take the lateral area plus the area of both of your bases. Now, both of your bases is, each of them would be pi r squared. Now, the lateral area is the area around the cylinder, this guy right here, right? You take the circumference of your circle and multiply it by height. So it's 2 pi r times h. 2 pi r times h. And that's your straight up. That's me giving it to you straight up, if there's a way to remember it there. So 2 pi times the radius times the height of the prism of the cylinder, that's 24. So 2 pi r h plus 2 pi r squared. And this is millimeters. This is the original, by the way. This is the first one. So surface area of object 1 before we shrink it will be this one. So let's do 2 times 24 is 48 times 9 is 408. I don't want to be wrong. 218 times 24, 432. That would have been way wrong. I don't know what I was saying. 432 pi plus 162 pi. I got that one. And that's 594 pi. And that'll be square, not inches, millimeters, square millimeters for that guy. Hopefully I got that addition right. Now, surface area of 2, we're going to divide these lengths by 3. Multiply them by 1/3. So the radius goes from 9 millimeters to 3 millimeters. So we'll do 2 pi times 3, and then 1/3 of 24 is 8. So 2 pi r h plus 2 pi r squared. So if all goes well, this should be a certain number. 3 times 8 is 24, doubled is 48. So 48 pi plus 9 doubled 18 pi, 66 pi. Square millimeters. Okay, we do the comparison of surface area 2 over surface area 1. Should be the same thing as k squared, basically, right? We should be doing 1/3 squared. But surface area 2 over surface area 1 is going to be 66 pi over 594 pi. Knowing that 660 is 1/10 and subtract 660, yeah, this should work out. So we should get 1/9 from that. So it should be 1/9 the size of what it was before, and it is, and we got it worked out. All right, now this one, we're just doubling the radius. This is one I cannot predict an answer for you because radius doubles is doubling 2 dimensions out of the 3. I could have educated guesses, but I don't want to be wrong. So surface area of a cone. Let's first draw this. I got 3 inches and 7.6 inches. And I actually don't need the height, I just need the slant height, just like I have right now. So 3 inches is the radius, slant height, perfect there. Surface area of a cone is the lateral area plus the area of the one base. The lateral area is pi times radius times slant height. This is slant height here, 7.6. And then pi r squared is your base area. So the original cone that we're looking at here, object 1, lateral area is pi times radius times slant height. And then we have pi times, I was going to write 9. Radius squared is 9, but radius squared. 3 times 7.6, don't want to make the mistake. I'm thinking 22.8. Yeah, 22.8. 22.8 pi plus this 9 pi gets us 31.8 pi square inches. This is surface area after all. So that's object 1. Object 2, we're just going to double the radius only. So the pi r l plus pi r squared, pi r l is still 22. Oh, no, it's not. We're doubling radius. So pi times 6 times 7.6. So we're effectively doubling that. But then we got to square this one. Pi times 6 squared. Okay, so now this will become what? 30, well, double that. 22.8 doubled is 45.6. 6.6 times 7.6. 45.6. So 45.6 pi plus 36 pi, which gets us 81.6 pi. All right, we got to compare 31.8 pi to 81.6 pi. Let's see what that's all about. Let me just do it right here in this area. SA2 over SA1. So 81.6 pi over 31.8 pi. Pi's cancel. So 81.6. I'm getting kind of just a different number. It's not really working. Let's do a fraction. 136 over 53. 136 over 53 times more. It's basically what I'm saying. That's not an x. That's a times, if you know what I mean. The number before was 2.56603. You know, it's just different. If I round, it's like 2.57-ish. But that's an exact fraction answer when all said and done. And I guess that's the one I'm going to work off of for the sake of this problem, because I don't know what they specifically want otherwise. Sorry about that. Okay. All right, let's jump to number. Oh, I never changed this little thing to a 4. I'm so sorry. So sorry. All right, that was number 4. Now we're moving on to number 5. We're halfway through, if all serves by duration that way. Describe how change affects the volume of a prism or pyramid. So, you know, I think we do. I think we are supposed to practice these things. Tripling the base and the height of the triangular bases. So we're not tripling the height of the prism. Okay, now we start with the original. Let's start with that. Triangular prism is, like any prism, is area of base times height. These bases are triangles. Got a scratchy nose right now. Sorry if you keep seeing me do this. All right, I got 12 feet, and 5 feet. Okay, so the volume of any prism, area of base times height. Now, the base area, in this case, is volume 1, by the way. That should be a 1. Area of base 1 is going to be 1/2 of the 5 times 12. Half of that is 30 square feet. The height of this object is and will remain as 12 feet. So the volume of object 1 is going to be area of base times height, which is 360 cubic feet. Okay. Item 2, we're going to triple the base and height of the triangular bases. So we are going to triple (5) and 12. So 1/2 of 5. We got to triple them. 15 and 36. Really makes everything 9 times bigger. This should be 270 then, I guess. 270 square feet. So I guess it's going to be 9 times bigger in the end. Height is still 12, so volume of object 2 is going to be 270 times 12. So 9 times bigger, 3240. 270 times 12. 3240. 3240 cubic feet. Okay, so yeah, that divided by that's 9. So volume 2 over volume 1 is 3240 over, what was it? 360. And that's going to be 9. 9 times bigger. For number 5. Number 6, multiplying all the linear dimensions by 1/4. Well, making it 4 times smaller in 3 dimensions will make it 1/4 cubed, which is 1/64 the size. But of course, we must do the calculations, I suppose. So let's go ahead and attempt to do those. Volume of a pyramid, or of object 1 in this case, is 1/3 area of base times height. Now, we're going to talk about B1 and H1 in this case. B1 is 1/2 its own little base times height of 12 times 16. Half of 16 is 8. 12 times 8 is 96. We get 96 square centimeters just off base 1. Height 1 is 20 centimeters, so we got to do 20 times 96 and take 1/3 of that. 1/3 of 20 times 96. Let's do 1/3 of 96 to start with. That's 32. 32 times 20, 64. 640? 640 cubic centimeters. Yeah? I'd imagine so. Object 2, excuse me, for object 2, it's area of base 2 times height 2, right? But now we're going to triple everything. So area, or take 1/4. I don't know why I said triple. 1/2. Okay, let's take 1/4 of 12. Let's take 1/4 of 16. And that'll give us 6 square centimeters, significantly smaller than the 96 you saw before, right? Height of this, you take 1/4 of 20, which is 5. And now we're going to take 1/3 of 6 times 5. So you can see, significantly smaller. Like I said, it's 1/64 smaller. It should be 10, because 640 is here, 10. 1/3 area of base times height. 1/3 of 6 is 2. 2 times 5 is 10. We get 10 cubic centimeters. And that checks out, right? That seems to work the way I wanted to do it. So volume 2 over volume 1 is 10 over 640, which is 1/64 times the size of what it was before. That was totally expected. We got it. All right. We got 2 more questions to go, number 7 and 8. These are the ones that have parts. Let's check them out. Number 7, you make the ball of aluminum foil shown. This is for sections 1.1 and 1.2. Okay, it's a 4-inch diameter. They do call it a ball, so we're thinking 3-dimensional, we're thinking sphere. So 4-inch diameter, diameter's 4 inches. Of course, that means radius will be 2 inches. I just wrote a 4. So I think we're going to have to be using that at some point. Don't know what the question is. Let's figure it out. Part A. You add foil to the ball, so its diameter is 3/2 times the original diameter. How does this change affect the surface area and volume of the ball? Surface area is going to be 2.25 times the size. Volume, I need to do this in my head first. Volume's going to be 3.375 times the size. Bank on it. So 2.25, 3.375. This is 1.5 squared. And I assume this is 1.5 cubed, because that's 3/2 cubed 27/8 should be 3.375. Okay, I think that's going to be it. All right, let's try it. Let's see. Original ball surface area and volume. Surface area of object 1 is 4 pi r squared, which is 16 pi square inches. Volume of object 1 is 4/3 pi times radius cubed. 8 times 4 is 32, so 32/3 pi cubic inches. Now we're going to make the diameter 1.5 times bigger, which makes the radius 1.5 times bigger. So R1 might have been 2, but R2 is going to be 3. Yeah, 3/2 the size. So surface area of object 2 is 4 pi times 3 squared. Whew, that's 36 pi square inches. And volume of object 2 is 4/3 pi times 3 cubed. 3 cubed is 27, divided by 3 is 9. 9 times 4 is also 36. But this is 36 pi cubic inches. Way different, of course, way different. So SA2 over SA1 is going to be 36 pi over 16 pi. 36 over 16 better be 2.25. It is 2.25. As a fraction, that's 9/4. So depending on which way you want to put it, that or the other. Volume 2 over volume 1, this should give me 27/8 or 3.375. So this is 36 pi over 32/3 pi. 32 pi over 3. I'll kind of write it like that. Now in the calculator, I'm going to want to do this. 30. I don't have to worry about pi. That's going to cancel. But 32/3. You can also multiply by 3 30/2. There's the 3.375. That's 27/8. That's how I got my number to begin with. 375 times or 27/8 times. Okay. So that's how they compare. I believe that's just part A, getting volumes and surface areas compared. Part B. Aluminum foil has a density of 2.7 grams per cubic centimeter. Find the mass of the ball before and after you add the foil. Now I'm seeing them say centimeter. We have inches. So first thing I'm going to do before anything else is a conversion before and after you add the foil. So we are going to add the extra foil. And I think at this point we can use the times multipliers and do the mass. Mass is going to be in reference to volume, not surface area. So we'll talk about density with that in just a moment. Let's start with the inches to centimeters. 1 inch is 2.54 centimeters. I don't know if that's expected for you to know. That's something that I learned and adopted over time. The book mentioned it once. I guess we go back to it. All right. So if 1 inch is 2.54 centimeters, 2 inches is double that, right? So I don't know that. 5.08 centimeters. And 3 inches, I don't know if we got to use it or we can use the other thing after. I think we can stick with this one, use that weight, and then just multiply by 3.375. I think that should work out. So we have this here. Let's do the... I'm wondering if we could do this without actually having to apply that. That's all right. We'll do it. So volume of object 1 is going to be 4/3 pi times 5.08 cubed. Let's actually work the calculator on this one a little bit more. 5.08 cubed for cubic centimeters is some weird number times 4, also weird number, divided by 3. I'm just going to use the rounded version here because otherwise it's just going to get wonky. It already is wonky to begin with cubing that. So it's around 549 point, I'll just put 14 cubic centimeters. I have another value written on my calculator. So I have this one written down right now. I'm going to use that one for the future things we do. All right, so this is the cubic centimeters volume of the ball. Density is mass over volume, and we have density of 2.7 grams per cubic centimeter. So density of object, density period of the foil is 2.7 grams per cubic centimeter. So what's the mass of the ball in grams? Right? They don't ask you what specific thing, so we're going to use grams. So 2.7 is mass over this volume, 549.14. So we got to multiply 2.7 by 549. Remember, I have an exact answer on my calculator, but I'm going to do 2.7 times that number. So that times 2.7. And here I'm getting 1,482.66662. So mass is about, I'll say 1,483 grams. I don't know if that's the appropriate rounding for that, but that's the one that I'm going to use. So 1,483 grams. Now, the next one here, when you do the, let's see, this is the mass of object 1. If I want to do the mass of object 2, remember, this should go in proportion with that volume that we had before. I should be able to take the 1483. Remember, there's a different number in my calculator. And I should be able to multiply by the multiplier of what happens when you increase everything 1.5 times. The volume will be 3.375 times larger, and the mass should be 3.375 times larger. So instead of doing that whole thing again, I literally just worked that thing out before. Mass works appropriately with that. So times 3.375, and here I should be getting 5,000, so I get 5,003.999. I'm going to round that. See, I'm using exact answers every time. Here's the 1482. I said 1483, sure. And times 3.375 is 5,004. 5,004 grams for the mass of object 2. Instead of doing all those same things over and over again, just to get what I had last time. So that's the mass of object 2. That is part B on number 7. No, that's part A still. Wait, what was that? Yeah, that was part B. Okay. All right. Last question, number 8. I don't know how much room I really need, so I'll just go to the next page. An ice sculptor is carving the block of ice shown. So it's like a rectangular prism, maybe a square. Well, it's a square prism with the 80 by 80. The block has a mass of about 745 kilograms. Find the density of the block of ice. Is it greater than the density of water? Explain. The density of water is 1 gram per cubic centimeter. So we have centimeters displayed for the blocks of ice, but they show kilograms on this other part. So 1 kilogram is 1,000 grams. So 745 kilograms is 745,000 grams. I'm going to use that when it comes to our density bit. The volume of this object is length times width times height, or area base times height, however you want to put it. We do want to use centimeters for this thing, so I'm already set for that. So 125 times a couple 80s, we'll put 80 squared, why not, is 800,000. Of course, 800,000 cubic centimeters. So grams per cubic centimeter is all about that density, right? Density is mass over volume. We have mass over volume. That's just less than 1. 745,000 divided by 800,000 is 0.93125. That's exact. 0.93125 grams per cubic centimeter. Okay, that's the density. And they say the density of water is 1 gram. Is it greater than the density of water? No, it is less than the density of water. This means that this thing would be buoyant. What is it? A block of ice. This block of ice would float in water because it's less than 1. Okay, that's part A, which I did not write an A yet. I'll do it here. Okay, part B. Another rectangular block of ice has a mass of about 298 kilograms. Give 2 possible sets of dimensions for the block of ice. Okay, we use the same density. Okay, so we can use this. We have the 0.93125. Let's determine the volume based on these kilograms. Let's call 298,000, or let's call 298 kilograms 298,000 grams. That's mass over volume. To find this volume, we're going to switch places of this. 298,000 divided by 0.93125. So 298,000 divided by this guy here. I'm getting, it's exactly 320,000. I'm glad it's an exact number. 320,000 cubic centimeters. So they said give 2 possible sets of dimensions for the block of ice. You can make it up. Any length times width times height gives you this. So let's make some stuff up. Length times width times height. Let's chunk away one part at a time, right? If 320,000 equaled 100 times width times height, then I can divide by 100 here. And now I have 3,200 equals width times height. And now I can, I don't know, I'm just kind of winging it as I go. I'll make one of these 160. I'll make the width 160, and then I'll make the height. Well, I guess the length would have to be, the length has to be longer than width, right? This should be length, whatever. That's okay. Divide that by 160, and you get 20. Okay, so dimensions can be 160 by centimeters. 160 centimeters by 100 centimeters by 20 centimeters. You can literally do whatever you want with these as long as you divide them out and they pan out to be from that number. So I'm just showing you a process in which how I came up with that. So there's one of them. That's one. This is open-ended as long as the numbers divide from that number. So let me try another one. Let's go to the calculator. I'm going to do 32,000 divided by, let's go 240. Darn it. Let's not use that number. Let's use, what's the number that would divide by that? 24 would work, right? 24, no it wouldn't. I don't know why I thought it would. Let's divide by 400. Okay, and let's divide by 400 is kind of big. Let's 16. We already did a 160. Let's do 800, 25. Whoops, not times, divided by 25. Sorry about this. All right, 32. So 25, 32, and shoot, what was the number? 400? Let's try that. 400 times 32 times 25. All right, so that works out. So a second set of dimensions can be 400 centimeters by 32 centimeters by 25 centimeters. Totally. I was totally creative with that, but it still works out, and we got it. All right, took me a little bit more than a half hour probably by making that happen, but that's okay. That is actually it, guys. that's the end of the quiz review thing on those things. That ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. Coming up next, 1.3 and 1.4 for the remainder of this kind of prologue chapter for IM3. So take care. I will see you in the next one.